Greeting guys, good morning to everyone and welcome to the last session of Git. We are going to have the last session of Git today, where we are going to complete everything about Git. We are going to look at how we can amend a commit. We are going to look at how we can handle conflicts when they occur. You are going to see what conflicts are, and you are going to see when those conflicts can occur. Then we are going to look at how to go back to previous versions of our code. We did say that the most important reason and objective of committing code is such that we can do rollbacks to our previous editions of our code. So we are going to see immediately how you can do that rollback. Then we are going to see what is the remote repository. In this case, we are going to be talking about GitHub. We are going to look at what a remote repository is and how it is being used. And probably by the end of this training today, you are going to create your own remote repository. And when you create your own remote repository, please take care of your password. Take good care of your password. And by the time you will start using your repository, I'm sure the token that you are going to create today must have been expired, because generally they give us tokens for 30 days and when you will start really practicing, your token might have been expired. So you should also make sure that you really grab the process of creating a token. So without any much to do, let us get directly into our demonstration board and start looking at what is an amend. So in our usual way, we have our main branch, and then we are going to have a code, a commit that is going to be created. This commit is going to be created and it's going to be in the file f1. We are going to create this file f1, and then we are going to create an a commit in this file f1. We are going to create an a commit. Now the idea behind commit, as we did say, is that a commit is a significant milestone that has been achieved in a project. The project can be, or the commit task could be, developing the user interface or the front face of an application in a website. And when you finish developing that front end, you can now commit it. It is an important milestone. But what if you do that commit? What if you do that commit and you discover that there is something that you failed to arrange? You needed to put a particular picture somewhere. What are you going to do? You are not going to put that particular picture and then come and do again another commit. No. Remember that we said commit are significant milestones achieved. There should be a significant milestone that is achieved in that commit. So in the case where you have not done a significant milestone, you have just simply corrected something in a particular commit, like the a commit, you have just simply corrected something in this commit, you are not going to recommit that correction that you have just done. You are not going to recommit it. You are just going to amend the previous commit that you just did, right? So that is what we are going to be looking at today. So let's get to our project page. Let us some sort of reinitiate. Let's delete our project. Let's start by creating school project. Now in our project, we have created a file. Let us first of all initiate. Let's initiate our repository. Can you mute, please? Okay, thank you very much. Let us initiate our repository, because without initiating your repository, remember that you are having a project and not a branch. You have to initiate your repository before you can have a branch. So how do we initiate our repository? Git init. And when we initiate, we have now a branch. Now here we can start writing our code. Let's take, for instance, we create a code. We create a file, and then we take this file into the staging area, and we give it an A commit. Fine. We have given this file an A commit. Here is the file here that we have just created. We have given it an A commit. Now, this file has been committed. Here is where we are standing. The file has been committed. We have an F1 file that has been given an A commit. Now, let us enter the file. Here is the file, please. Let us enter the file. We want to enter this file. We open by Notepad, and then we add something in the file. Let's say we add 2 lines of code in the file. We have added 2 lines of code. We save. When we save, what are we going to have in our repository? We are going to have git status. Look at git status. We have a file that has been modified. But when we run git log -1 line, we see that we have an A commit. Now, this is what we want. We do not want to see an on-track file. We want to see the on-track file committed, but we do not want to create another commit. We don't want to create another commit, right? We are not creating another commit. We want to just modify this file that has been modified. We want to just merge it, put it inside this one. The idea here is that you are not going to have a commit. You are going to amend this file. That is what we are calling git amend. We are going to run the code git amend. Let us see the code we are talking about. We are going to run this code git amend. Okay, git amend git commit amend -a. This is the code that we are going to run. All right, so if we run the code git commit -amend -a, look at what will happen. While running this code, Git will ask us that, Git is going to ask us that this thing you are trying to do, what has happened before you are trying to merge? Write me a statement which I am going to understand that you corrected this code. So if I run git commit -amend and I execute, you see Git carries me directly into the VI editor. In the VI editor, here it is written here a commit, right? Now I can decide and allow it as an A commit. It still remains an A commit, or I can decide and change the commit comment. Instead of having it an A commit, I can have a B commit, I can have a C commit, but I don't want any comment. I just want it to remain as an A commit. If you wanted to change the commit comment, you can now press enter. Look down here, there is no insert down here. When I'll press enter, insert will show down here. If I press enter now, I can delete this A commit and write a different commit, but I want the new file that I've just added to be merged under the A commit, right? So I just press escape, which is going to save, colon, wcure hyphen, and I leave. Now let us run git status. Look at, when you run git status, you see on branch, nothing to commit, working tree clean. Did we commit anything? We did not do stage, we did not move to staging area, we did not write a commit. We just simply amended our commit, right? We never moved the modified file to the staging area and took the file again to the commit area and giving it a different one. We did not do that. We just simply modified an existing commit. So if you run git log hyphen one line, what are we going to see? We still see that we have only our a commit that is there. Our a commit is there. There is no new commit that is there. Only our a commit is there. Only our a commit is there. There is no new commit that is there. So the idea here is that, let me bring you back to the design board. The idea here is that you create a commit, you create an a commit, and remember that a commit, please Renee, can you mute? Remember that a commit is an important milestone. A commit is an important milestone, which means it should be a very good task that has been accomplished. Not that every single change that you do in your code, you go and commit. Every single change that you do in your code, you go and commit. No. A commit should be a task that has been given. For example, if you are given a task to build the interface of the website, until that interface is fully built before you commit it. So when you are committing it now, you say that interface of the website built. Then you commit it now. Now, if you build that interface of the website and then you discover that instead the interface of the website, we are in the YouTube interface right now. The commit of somebody was to put this advertisement, put this thing, and align this one. He has finished it. He decides to commit it. And then when he commits it, he discovered that, hey, the YouTube icon that is found here, it is instead found but here. Let me bring back the YouTube here. If you correct that little error of bringing back the YouTube here, it is not a huge thing that you should commit. That one you should amend your previous commit. You should amend your previous commit. That is the use of amendment. Okay, you should amend your previous commit. Good. So at this level, we understand the meaning of amending a commit. Where are we standing? We were to look at git amend, and then we were to look at handling file conflicts. Look at the way file conflicts can occur. Take a look at the way file conflicts can occur very well. This is a commit that we have just committed. It is an a commit. Remember that I said whenever you create a branch, whenever you create a new branch, right, this one like this is the main branch. This is the main branch, and then we have created a new branch which we are going to call it the test branch. Okay, these are two branches. I said whenever you create a branch, the commit history of the main branch is copied to the child branch. Here in this branch that we have created, we are going to have also this very a commit is going to be found in this branch. This a commit like this, and the same file is going to also be found on the child branch. This file like this is going to be committed, it's going to be copied. So this file that you are seeing here is not this one, it is a copy. We have the branch copied everything from the main branch to the child branch, and then they tell you now that keep on writing your commit. Okay, imagine now that we have created a new branch. This is a new branch that we have created, and we are supposed to start writing other new code in order to commit. Instead of writing other new code, we came and we developed a real milestone in this very commit, the a commit. We developed a good chunk of milestone in this commit and we decided to commit it anew. Let's see how that happens. Now we are here, we have created an A commit here, right? We are in the main branch. Let us create a branch, git branch test. We have created a branch and we are moving to that branch, git checkout test. Now we are now in the test branch. To show that the commit in the main branch is copied in the test branch, if we run git log -- one line, we will see the A commit. The A commit is here because it was copied from the main branch. But whatever you do with this A commit here now, you are doing it with a copy, not with the former A commit of the main branch. I hope we get the idea. Whatever you are manipulating with this A commit at the level of the test branch, you are doing that with the A commit of the test branch, not the one of the main branch. Take a look at what we are going to have now here. Let me bring the good. We are here now. Look at what we have. Let's open the file. This is what we had in the main branch, right? Let us say that, okay, instead, after we have copied the branch to the test branch, we write a real good amount of 5-line code. Okay, we have written a good amount of 5-line code. We save the code, right? We save the code, and then what do? We commit the code, like we say git add and git commit. We commit the code now with what? We commit the code with a B commit. We commit this code with a B commit, like that, right? The code gets committed. It gets committed, no problem. Where are we? We have amended or committed, changed this code and has recommitted it, right? Now it is still the same file f1. We have not created another file. It is still the same file f1 that we have gone into that file and we have done another commit. If we move back now to we go back to the main branch, and in the main branch we still work on the f1 file and do another commit. We created this file in the main branch, we copied it to the test branch, we worked on it and created a commit, and then we moved over to the main branch, we still worked on this file and created another commit on the same file. So let's see how it works. Now we are in the test branch, we move over to the main branch. Now we are now in the main branch. To show you how things work, look at that file that we created. Let me open that file that we created. Here we are. Remember that we wrote a 5 code line. Remember that we wrote a 5 code line, right? Now when I open the file, see whether you are going to see that 5 code line. Are you seeing any 5 code line? But I'm opening the same file, F1, but you cannot see that 5 code line. What has happened with the 5 code line? It was never created, or that 5 code line was never created in the main branch. It was created in the master. If we move over to in the test, please. If we move over to the test branch and then we open this file, we are going to see these 2 lines plus another 5 code line. Let us try it as you see. We are now presently where? We are presently at the level of the main branch. We have opened it. We cannot see the 5 code line. Let's run git checkout test. Now we are now in the test branch. Let us open the file now. You see, in the test branch now, the 5 code line shows, right? That is to show you that the same file found in the master and found in the main have 2 different attributes. It is not the same file, they just simply have the same name. Okay, so let us move over to the main branch and we create another commit on the same file. Git checkout main. Now here we are going to create another code. Let us create a 4-line code. Okay, we create our code, we save. When we save our code, what will happen? We have an on-track file. We have an on-track file, right, that has been modified. We take this file to the staging directory and we give it a commit. Let's give it now a C commit. What are we having now presently, guys? We are having one and the same file. We are having one and the same file that has A, B, and C commits. It is the same file that has both A, B, and C commit. This is now our C commit, and it is still what? It is still F1. All throughout it is F1. So now, if we try to merge, we are trying to merge the test branch with the main branch. Git will not understand what you are trying to do. You have a file, it has a different content here. You have another file, the same name, different content. You are merging it with the same file, different content. What do you expect Git to do? It confuses. It doesn't know what to do. The merge will fail, right? The merge will fail. We have a file here. We created a file here, and then we created a test branch. And in that test branch, we copied that file. That test branch automatically copied that file. And then we modified the file and had a commit. And then we moved over to the main branch. We took this earlier file that we had, we modified it in a different way and had a different commit. You take this file, you modify it here. You take this other one, you modify it here. Now you want to merge. All of them have the same name. What should Git tell you? Git will tell you that it doesn't understand what you are trying to do, right? So let's try to merge. We are in the main. Remember that when you are merging, you go to the master branch and then you call the child branch. So we git merge test, right? When we run that, look at what happened. Look at the statement that occurs. Conflict content merge conflict in F1. There's a lot of conflict in that F1. The same F1 is found in main branch and the same F1 is found in test branch, and you are trying to merge, but they have different content. What should I do? That is what Git is going to ask you. When you have this merge conflict, this is our lesson for today. When you have this merge conflict, this is what you do. You are going to enter the file itself using your VI editor. VI, that's how you enter the file. VI F1. You enter the file. When you enter the file, this is what Git is telling you. First, I had this code. Second, I had this code. Third, I had this code. Which code do you want to merge? Do you want to merge all the codes, or do you want a particular code off? It is now the call of the developer, because you are the one to decide which code is being merged and which code is remaining. Do you want to merge all the code or do you want to remove some? If I wanted to merge all the code, I want to say that yes, all these codes are good. It is actually me who did it and I know what I was doing. You press your insert and then you come down here, you remove these lines. You remove this line, you come down, you remove this one, come down, and you remove this one. Certainly, okay, good. I've removed all the lines. Now your code is now 1. Okay, your code is now 1, right? What you do is you save it and then colon wq exclamation sign, you quit. Git status. Now both files have been modified and you can now merge. Look at what is happening. We have the main and the merging, right? You can just give now a commit, git add, git commit. Now you can put a decommit. Now your files are merged without any problem. You don't need to go back and be merging. You don't need to go back and be merging. Your files are already merged. So git status, we'll see that there is nothing to commit. Git log hyphen one line. You'll see that we created A, B, and C commit, and we have a D commit that is in the main branch and it has been merged. If you care, you run git merge test. What are you going to see? Git merge test already up to date, right? The branch was already merged and it is up to date. That is how you deal with conflicts. That is the way you are going to deal with conflict. I hope that is very clear. A general question in the interview always: how do you deal with conflicts when files are having the same names but containing several commits? You are the one to discuss with your developers. Set up a meeting with all the developers and then manually enter into the code with what Git is going to provide to you and seek the advice of the developers which code is actually important. Then you eliminate the code that is important, or if all the codes are important, you join all the codes by eliminating the line separating the code, because Git is going to give you the codes in separate lines. Okay, here we are standing. We have handled conflicts. So the next thing is, how do we go back to previous versions of our code? Okay, we have just done a merge, but we discovered that this merge, we did not want to do it. We never wanted to do this merge. It is not a merge that we wanted to do. We want to roll back. We want to roll back into the previous merge, right? Into the previous commit, not the previous merge, into the previous commit. Remember that we had A commit, B commit, and C commit. Now we have just done the D commit that merged the branches together, right? But we want to roll back into our C commit. What you do is you simply copy the commit ID and then you run the command git reset hard, and then you write the commit history. Let's say we wanted to come back to C. The commit ID of C is B0 8F. Let's just copy in order not to have a conflict between 0 and O. You copy this one. Sorry. So git reset --hard, then commit ID. A general ask question: what is the command to roll back to former commits or to previous commit? Git reset --hard commit ID. When I run this, head is now at this commit ID. So if I run git log --one line, what am I going to have? The D commit is no more there. I can roll back now into my previous position. I am now at the level of the C commit. The D commit is no more available. All right, I am at the level of my C commit. Okay, that is how you can roll back to your commit. Before we move over to remote repository, any question, any confusion? Okay, in the absence of no confusion, we move. All right, we are talking about git remote repository. Generally, we said that git is what type of a version control. What we have just done now is version control in git. So the question can be, how do you perform version control in git? You can say git has the capability of rolling back. Git has that capacity to roll back. That is performing version control in git. All right, what is GitHub? What is remote repository? We said there are two types of repositories. We have centralized repositories and then we have distributed repositories. Take a look at this. Come over here. Let us see what is a centralized repository and what is a distributed repository. How do they function? There is a saver. There is a saver somewhere here, right? And then there are developers here. 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 There are developers all around the world. Now, when each developer finishing developing his code, he sends the code here. When this one finishing developing the code, he sends the code here. When this one finished developing the code, he sends the code here. Let's say there were 3 of them. These developers, there are 3 of them. They have done their code. They have sent their code here. This is the difference between centralized and distributed version control. Remember the 2 words. We have centralized. We have centralized. And then we have distributed. We have centralized and we have distributed. Now, look at, for centralized system, if the project started with 3 developers, and these 3 developers have already uploaded code into this system, and then the project needed an extra 2 developers, right? They will contact these 2 developers. Maybe the project was running in USA, Europe, and Asia. Now they needed 2 more developers from Africa. These 2 more developers are coming in. What are they going to do? They are going to start writing their own code on their own machine, and they will also be committing the code to the central repository. Who has seen a problem? Who has seen a problem? Who has seen a problem at this level? There were first of all 3 developers. They started a project. They have gone almost 25% into the project. They are writing their code and pushing to the centralized system. They write their code, they push to the centralized system. Now, 2 other developers have been added. They are coming after the project has started. Now, they just join in, they start writing their own code, and they are pushing to the central system. Write their own code, push to the central system. Question: who has seen any problem that might arise? We should be looking at things from very conceptual point of view. Just forget about the fact that it is IT, it is programming, it is, just use your sensitive knowledge, your normal physical knowledge. Who can tell me what is wrong at this level? Okay, look at something. If you join the group and the group is already 25% gone, 25%, they are already 25% gone, you are still at 0%. You are still at 0%. Don't you think that you would like to know what this group did before you continue? Isn't it necessary for you to know what was happening before you came? You have to know. You have to know where they are. You have to know where they are situated. You have to know what strategy they are using. And then, even though you are given a specific task which is not their task, but your task is going to communicate with their task. So how can your task work without their task? Right? So for centralized system, this problem occurred. Where developers will develop their code, push to the central system, and then they need extra developers. The extra developers come, they start developing and pushing to the central system without knowing what the former developers actually did. That is a problem. So the centralized system is no more in action. Nobody uses the centralized system anymore. This system is no more used. There is still a tool which is a centralized tool. I think it is a VSC. They will always ask you what is the advantages of Git over VLC. VSC is no more mostly used again because it is a centralized unit. Now, distributed. How does a distributed system function? In the distributed system, look at what will happen. In the distributed system, these developers are already 25% gone into the project. They are already 25% gone into the project. And then the 2 new developers that come, what will happen with the 2 new developers? They will, first of all, the very first thing that they will do is they will download, excuse me please, they will download the code. They will download the code. First of all, they will download the code to their machines. So first of all, download this code to their machines, right? How will they do it? They'll run what we call git clone, and this code will be in their machine. This one will download the code. This one will download the code. And all the code that is found in Git will be in their machine, right? When they first of all download the code, after they have now all the code that these people are having, they have all the code that these other people are having. They already have also, they can now already have also the 25% of the project, right? They have the 25% of the project. when they have the 25% of the project now, they start developing. They can take it now from there and then develop another, maybe another, let's say 60% of the project. They'll develop another 60% of the project. And when they develop another 60% of the project, what do they do now? They will now push the project back into the repository. They'll push the project back into the repository, right? They'll push the project back into the repository. And when they push the project back into the repository, what will happen? The moment they push the project back into the repository, these people, if you must continue doing, you first of all have to also download the new product that these people have pushed. These people are at 60%. So you should first of all download what these people are having. Before you can continue coding. You download it before you can continue coding. So that is the difference between centralized repositories and distributed repositories. Centralized repositories are no more used. Distributed repositories are used. In distributed repositories, you first of all download all the code that is in the centralized system and have it in your local machine. Then you continue writing code. When you finish, you upload. When there is a new code that is here, these other developers will also download it, have it in their machine before they continue coding. Now somebody will ask, what if I have the code in my machine? This one has the code in his machine. All of us upload the code at the same time. Git does the aspect of first come, first serve. If you upload the code at the same time, or once the code reaches here, the first person's code that enters will be given priority. It will enter and then get updated, and then Git will send you a message that the code was updated. You download the code first, and then before you upload with your own new code. Okay, so that is the issue about distributed and centralized system. So let's see what the remote system is with Git. The remote system is this remote system like this. What is it actually? What is this remote system? It is actually what we call GitHub. It's just a site. It's a website. Just go to Google. Let's go to Google, and then you type GitHub. And then you come to sign in. It is actually this one like this, github.com. Come to sign in. When you come to sign in, if you already have an account, they'll ask you your email name or username and then your password. It's just like a Facebook type of thing. We all know how to do these type of things. You just sign in. Now, if you don't have an account, you come to create an account. When you come to create an account, you will be asked to give your email address. You put an email address, you continue. Create a password, right? I want to create a password. My password is strong. Continue. Re-enter your password again. Continue. I have to come to my email. Okay, so this is what you are going to do. You're going to create your password, and then you re-enter your password. No, this is enter a username. excuse me, my username will be ranks. Username ranks is not available. Okay. 1U clearance. 1U clearance is now available. So when you are creating your username, you look below here. I would like to create Clemerance 1. Clemerance 1 is available. Okay. Would you like to receive product updates and blah 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 blah? Of course you like. Please solve this puzzle. We are about 11 minutes to drop. Please solve this puzzle to verify that you are human. Click start puzzle. Okay, let's see the puzzle. Pick one square that shows two identical objects. Which is the square that shows two identical objects? I think it should be this square that shows two identical objects should be this one. Pick one square that shows two identical objects. Two identical objects will be this one. Okay, create account. You are almost done. We sent a launch code to clemerance@gmail.com. So I come here, I see if they actually send me the code. Can't see the code. Let me make sure I give the right address. Yeah, this is the right address. So the code will certainly come, and then you're going to use the code. It might be taking some time. Okay, while the code is taking some time, let me log into my official GitHub account and show you how the account is while this code is taking, because when the code will come, all we need to do is we come and insert the code here, and that's it. We are done. So while we are waiting for the code, let me log into my GitHub account. So I don't have to do this with the same browser. So let me go to Chrome. Okay, my code is there. It has come. So here is my code. I doubt if it can be copied and pasted. Every Cameroonian will always try before giving up. Wow, it was copied and pasted successfully. How many team members will be working with you? This will help us guide you to the tools that are best suited for your project. So how many team members will be working? You can see a normal DevOps team is always, average size is always 2 to 5, large medium size 5 to 10, large size 10 to 20, enterprise version 20 to 50, Facebook version 50 plus, right? So I am just a teacher, and I want 2 to 5 people working in this account. You can put just you. There's no problem with putting just you. What specific features are you interested in? These are just areas where they are going to help you arrange and set up your Git, right? You want to do automated CI/CD because that's the main thing we are creating our Git for, and we are going to be doing community and project management. We go ahead. You can click as many as you want. It is your real world tools. Engage students, free. There are free gifts and there are paid ones. So since we are going for the free one, you click on free, and finally we are in the Git repository. We are initializing our repository. Okay, this is a new Git repository that we are just in here. So while inside this repository, the first thing you are going to do is you are going to create a token. You are going to create a token. That's the very first thing you are going to do. You are going to create a token. What is a token? A token is a string of code that is going to help you to have access to your Git. That's going to help you to have access to your Git. So first things first, we enter our dashboard. We are in our dashboard. We go to settings, where we are with settings. We come to settings. All right, when we are in settings, you come right down to developer settings, and then under developer settings you take personal access tokens, take classic, generate a new token, classic, and then what is this token for? Admin purposes. They will always ask you, because you can create tokens and give to your collaborators. The token will stay for 30 days. You can reduce it. They will always ask this question in the interview. How do you manage your lock-in? What if you had a programmer in your project and that programmer has to leave your project when he's already having a token? What are you going to do? The thing is that you create tokens that will self-destroy themselves after a particular period of time. Okay, this token that we are creating should last for 30 days. Let the token do all admin things. You can decide what a token is doing, but I want this particular token to do everything administration. You see, I'm clicking everything admin for the token to do. Clicking everything admin for this token to handle. Okay, you will always be creating tokens after 30 days. They will send you information that that token is expired. You create another token. Without a token, you cannot push your code to your repository, right? Without a token, you can never push your code to your repository. I've done everything now. Generate token. Now this is the token that has been generated. Please always keep the token very safe. What I do is I take the token and I send it to myself in WhatsApp. It is there, or I send it in. The token is also sent to you in your email, right? So always keep the token ready for use when you want to work with Git. Our token was generated from Git. This is a token that was generated from Git. We have generated our token. Right now we have stored our token. The token will also be sent to you in an email, right? The token will be sent to you in an email. Let's check my email and see. You will see this is a token that has been sent to me. A personal access token admin with admin enterprise and everything admin was generated. To see this and other security events for your account, visit that. If you run into problems, consult that. So let's see if we can have Okay, they are welcoming us. Okay, they are telling you now that to see the token, visit this place to see the token, this one. Okay, so that token was generated for you. So what should we do with this token? How should we use this token? We have generated a token. Here is a token. How should we use this token? Here is how you use the token. Come back to Git. Here is Git. That is the way Git is set. All right, let's come back to home. To come back to home, you just come here. This is the home page of Git. Here I have no repository. When you are going for interviews as a DevOps engineer, right? When you are going for interviews as a DevOps engineer, they will always ask you, can we see your GitHub account? Please, can you push us our GitHub account? Why are they asking for your GitHub account? They are asking for your GitHub account because they want to see projects that you have done yourself. They want to see how many projects you have done on yourself. Because every project that you do, you should have pushed it to GitHub, right? In most of your research that you are going to be doing, you are going to be looking at people's GitHub account. There is a GitHub account that is public. Many people, when they push their work to their GitHub account, they always put it public, and there's a GitHub account that is private. If you want your project to be private, that is, nobody should see your project, you put it private. If you want your project to be public, that's any Jack and G can see your project, it should be public. And for us developers, since we are not developing a particular specific project for somebody, we are doing practice, we are showcasing ourselves, your GitHub should always be public. Okay, we need to create a repository in GitHub. We need to create a repository in GitHub. In order to create a repository in GitHub, there is it here, create repository. You can come here and you create your repository, right? Just come here like this, click create, and a new repository is going to be created for you. Give the repository name. This one is DevOps 100. That's the repository name that I'm giving, right? And I'm putting the repository in public. Okay, generally you always put the repository in public. They will always ask you, do you want to add a readme file or all the like? You don't need to add none of those. Create repository. I create my repository. Now my repository is created. Here is my repository that has been created. This is a new repository. What is a repository? A repository is like a house, right? It's like a room in Git. GitHub is the house. A repository is like a room within that house, a room that contains a particular code. So we have created DevOps 100. That is our room. We are going to be pushing the code that we have just created. We created the code. You remember we created this code? We created this F1 code. We created this F1 code. So let's create two more codes within our project. Clear. Let's create F2 touch F2. We move it to the staging area. We create a commit. We put it on F commit, and we create the last file, touch F3. We move it to the staging area and we create a commit. Okay, now we have how many files? We have 3 files in our project. These are the 3 files that we have in our project. We want to push these files to our repository, to our newly created repository. We want to push these files to that repository. The first thing that you are going to do is that what? Instructions on how to push files to the repository is given in the repository. The first thing is you must initialize your your repository, your local repository, you must initialize your local repository, right? When you initialize your repository, you commit the files. When you commit the files, we have already run our commit. You run git m commit and all the like. Then now you run this folder, this code, git remote add origin that you run this code, right? That's what they are telling us to run now. When you run this code, you are going to attach your local repository to your remote repository. That is attaching your local repository to your remote repository. Let me run the code and you see. When I run this code, now my local repository is now attached with my remote repository. I can now push my code, right? I can now push my code. Look at the code. This is the code. This is a code to push. Git push is always a good practice to write rather than copying. Git push -u. This question was asked to me in one interview and I failed it. I did not know. What is the command to push code from your local repository to your Git remote repository? The answer is git push -u origin main. When I push this, do like this, technically my code will be pushed. Let's wait and see whether it will be pushed. They say git push -u origin main remote permission to clearance git denied, fatal, unable access. Why can I not access this code? Remember what we talked about, what our token. We have not yet linked the repository with our token. We need to link it with our token first. Okay, after we have linked our repository, in trying to push, we will need to connect our local repository with our main repository, with our remote repository. So how do you connect your local repository with your remote repository? How do you connect your local repository with your remote repository? Come along to the git command here. This is our command to link or push. Technically, what you do is you copy everything from here. You come to GitHub, to Git branch, you put. It is going to give you a window, is going to pop up for you to link. Where is that window? There should be a window that needs to pop up for us to link our code. Git, are we in the branch? Git status, we have everything committed. Git push origin main. Okay, let me link it again. I think I needed to link it again. Error, remote origin already exists. Okay, if my remote origin already exists, then my branch, is it the right branch? Let me see if my branch is the right branch. Good, I am in the right branch. I am supposed to push now, and then okay, let me sign in and sign out. Sign out and sign in, please. I have to sign out from somewhere here. Okay. They say my browser did something unexpected. I was expecting this because my browser is not responding, which is supposed to be responding. Okay, I put my address, put my password, okay, here am I. Do I have any repository created? Yes, I have a repository created. This is my repository created. Okay, good. With my repository created, can I push? Let me see what they are trying to say. Okay, guys, let us use my main address and I demonstrate to you how to push this code so that we don't spend time. I will look at what is happening at the level of this one. Let us use my main address, my main Git account. When you are logging in, they'll always like to send you something for you to, a code for you to accept that you are the one. So when you are logging into Git, you should also always make sure that you are your email is open somehow. Okay, let's create a new repository in which I call the repository DevOps 101. It's a public repository, and I create my repository. Okay, now let me link my repository to my local okay, let's do one thing. Let us create a repository, a local repository. Okay, let us just create one file. What am I seeing?
So you were to do git init first.
Thank you. Okay, that has been done. Now let's see if we can okay, it links properly. Now under normal circumstances, I'm supposed to push, and then a pop-up message comes up to tell me that I should put my username and my token. Enumerating objects done, writing done, branch setup, track origin main. It has been pushed. It is not supposed to push without telling me, prompting me to put in my token. So let us initialize and see if it has been pushed. It has been pushed, F1. This is a file here that has been pushed. Now generally, please, when you run git push, I don't know what has just happened. When you run git push, there will be a pop-up box that has to pop up for you to put in your username and your token. Okay, there will be a pop-up box that will pop up for you to put in your username and your token. Then you put in the username and then you put in the token, and then all your files will be uploaded here. This is a new file that we have just created, and all our files are uploaded here. In most cases, you will see most DevOps engineers will tell you that go to my GitHub account. You will see all the files that you need. We can actually see the GitHub account of so many engineers. You see how their GitHub accounts look like. It is from here now, all the code that developers are going to be uploading will be found here. It is from here now that the code will be picked up. All your codes will be picked up from here, and then they will be sent to the next tool, which we are going to be discussing in probably our tomorrow's class, Maven. Tomorrow we are entering into Maven. Okay, so guys, any question? This session was a bit long because I just wanted to finish everything Git. I did not want to keep anything for tomorrow. Just wanted to finish everything Git today. Any question? All right, let me say something here. There is a way to study. There is a way to study. I'm having interactions with some of you, and some of you are so much eager to finish the program and not eager to master the program. You want to run to the end without actually mastering the program. Take for example, we are finishing Git today, but you cannot tell me that we have done virtually everything in Git. It's a lie. We have not done virtually everything in Git. If I said that I should tell you everything that occurs in Git, we are going to take 2 months alone only with Git. But this is what a DevOps engineer should actually know as far as Git is concerned. So what I expect you to do is go to the internet, search more about Git, search more about branching, search more about merging, search more about the various type of branching, because there are 3 types of branching. There is a branching in which you have how do they call it? You have a task branching, you have a feature branching, and then you have that is the task branching is a branching where you branch because you want to finish a particular task in a particular branch. And then there's a feature branch where you branch because you want to create a new feature of that application in that new branch. And then there's another different type of branching, right? So, and they can ask you that in the interview. We have not done it. So you need to go in, search for those different types of branching. You search for them, okay? And then you need to go on. What is research? How do they perform research in the industry? Go now. This is time for you now to enter into YouTube and watch everything that concerns Git, and even start looking at Git interview questions and start practicing. Now, when we do Maven and finish, and then start entering into our Jenkins pipeline, now you are already real engineers. Now that is when you can start calling yourself engineer. At least you can already enter an IT company and say that you can actually manage a software after we have done Jenkins. Because when we will do Jenkins, we'll finish all the 5 stages of a Jenkins pipeline that is going to be used with Git, GitHub, Maven, and then we are going to integrate Jenkins with it, and then other small tools that we are going to use in incorporating with Jenkins. After Jenkins, you can now start telling yourself that you are now a junior engineer, right? At this particular moment, please spend your time on knowing the best, mastering, understanding the concept. That is what you should be doing, understanding the concept. Somebody asked me a question offline and said that I was so afraid to ask the question in class because I'm afraid that I'm going off topic. No, those are the questions that I need. And his question was very, that means it was logically asked, but he is afraid to ask the question in class because he thinks that the question is stupid or whatsoever. No, it is when you have that ground understanding of what is actually going. Because he asked me the question, now tell me, really,
Tell me really. Does it mean that git commit is a space or is it a physical file? That is a question that he asks. I mean, and some people will just be sitting in class and accepting git commit. But if they ask you what is really a commit, maybe you cannot explain. So guys, when I ask your questions, ask them the questions. And now that is the importance of following the lectures with a lot of concentration. Another thing I discovered with somebody also is that he just come and sit in the lectures and then go away, because maybe they think that when they will go back to read, they will understand. But the type of question that they will ask you offline, you ask like, wait, did you not follow the class, or have you not watched the videos? Guys, if you don't follow the class step by step, watch the videos frame by frame. It is going to help you. It is going to help you. All right, watch the videos frame by frame. It is going to help you. They are going to help you. My greatest prayer is for me to train you guys in such a way that you are not going to go through 2 or 3 or 4 interviews and then you succeed. Because I'm training you. This is not how I was trained. I tell you the truth. This is not how I was trained. I did a lot of work myself. But now I'm struggling to put all those together and give it to you, such that when you are arriving in the level of the interview, you are already perfect. Because they will ask you a question. What do you do in your general in the company where you are right now? What are you doing there? What is your daily activity? After having done Git already like this, you will say that whenever there is a project that has just come into our company, I am in charge of setting the GitHub account. When I set the GitHub account, I set every dependencies of the GitHub account, and then I share the GitHub account link code to all the developers. Then the developers start writing code and updating it into GitHub, and then I construct the pipeline that will capture the code from GitHub and run through various stages, such that the code is totally deployed automatically into servers. That is my job that I do every day at work, because they will always like to know, are you really employed? What is it that you do every blessed day? Okay, so this is what you should be thinking. Search, go inside deep, read documents, go into Facebook, whether into YouTube, and read things, and then practice. Practice is the main thing. Practice all the times. Okay, so guys, see you guys tomorrow. Any question, please? All right, we'll meet tomorrow, God willing. I pray so, because I have a very busy day tomorrow. I will confirm, maybe tomorrow or this evening. All right, see you guys tomorrow, God willing. Bye bye.
Okay.